Ahoy Captain and welcome to this Shore Power Quickscan tool tutorial. This could be my favorite tutorial ever because, well, I'm just such a big fan of shore power and we finally made the tool available for public. And this tool will provide you a business case for a shore power refit on board your vessel, and it will include many operational expenses including regulations such as fuel EU. It's intended for paid users, premium members, but don't be scared, it will also show you how to make such a case yourself. So if you're interested in buying or you're a member and you need guidance with inputting it in the tool, feel free to skip to the fun parts where it is applicable to you. Before we start, however, a few disclaimers from our part as always. Please keep in mind that this tool is an estimate. I mean, I wouldn't say, or usually I say it's simple, not easy, but this is not even easy. It is quite complicated if you want to make a good estimate for your vessel. So it's going to take somewhat longer than usual. Please bear with us and don't be scared. We'll do everything in small steps, but keep in mind to do a sanity check at the end and always think for yourself if the things that we propose also apply to your ship type. Speaking of ship types, it is ship type but not ship specific. We have a list of about 50 ships that we input to make some sort of a modeling and cases. We are working on a lot more, but keep in mind, well, it's not your ship. We don't know your ship, so we make estimates on the ship types and also which rules and regulations apply. And finally, we keep on changing the feasibility study, not just the technical and the economic parts as the standards, the technical parts and the costs progress, but also of course the regulations. So also there, always do a sanity check and check with your verifier. If at any time you have any questions or you need any clarifications at all, luckily we are there for you because you can always contact the help desk to make your life easier. With a click of the button, we can look with you and see how to help you in your specific case. So, a very long introduction to something that's close to my heart for many years. Let's dive into the Shore Power Quickscan tool. And here's the beauty. Shore Power Quickscan. Please be mindful, we are working on the premium member page, so if you are using the freemium web tool, some features might be excluded. If we scroll down, we see we can select any ship main type. We're gonna go for, let's see, cruise passenger ship, because, well, they're already being outfitted with a lot of shore power. And there we only have a single option, so we're talking about large cruise passenger ships. And if we press let's go, we automatically dive into the fun part. So here we see a Capex, OPEX, the costs. But well, that's just because most of you are interested in the cost, but we're going to go from 1 to 5 and from top to bottom through the entire tool and show you all the specifics. So first we have ship details, operational profile, very important. Then equipment details, how many connection panels, rated power, etc. And that will translate itself into a certain amount of Capex and OPEX. And then finally we can change or play with some of the input parameters such as fuel to make a business case, and we can save our case in the end so that we have something to show to friends, colleagues, frenemies, or mostly management. So let's first start with ship. So here we have the AIDA Cosma. It's a standard ship. The Premium XL will give you the option to customize almost everything. Amount of idle moored days, that is a lot, 200 days of course. This will greatly positively impact the business case, so we're going to go for a little bit less, 120. And we've also included that not every idle moored day could be a shore power day. For this exercise I will do so because it's easier to show where the differences come from. But for example, if of your idle moored days you only have like 80% availability of shore power or not at all ports, you can input it here. It remains an estimate of course, and we can always change it later. So if we scroll down, we can see in ship properties here all the main equipment, generalized parameters. Not everything is included or customizable, but we can do that in the Excel in the second part. Power demand, and this is of course I wouldn't say where the magic happens, that's probably at the business case end, but here we see that the auxiliary power installed for this ship type is quite high, with all those air conditioning and all those lovely people having a great time on board that need some cooling with their activities. So make sure to check the maximum installed auxiliary power, the power used maximally while in port, and then we assume a certain amount of auxiliary engine load. So basically we translate the maximum power into a average auxiliary power. You know from experience that typically it's a lot less, but it really depends on ship types, and for these ship types it's probably maybe a lot more even than 20%. It all depends on the conditions, of course, but we're going to go for a nice 35%, resulting in an average of about 5 megawatts of power. That also coincides nicely with the standards. Parasitic load, that one is quite important. What it means is that if you have your engines running, there's a certain amount of parasitic load in order to run the engine. So engines need fuel pumps, cooling, fans, etc. in order to run. If you shut off the engine and use only electrical power, you could use a lot less energy. So you can change that amount here. You can also leave it at 0 if you simply state that, okay, I don't have any parasitic load, I simply want to have an average power amount for my ship. And you can also change your operational profile if you have like peaks per day. So if you have peaks while loading or unloading or anything else, you can change it here, change the maximum peak power according to your maximum auxiliary power. We're gonna just leave it at 0. So we have a power demand. The next step, very important, is to translate power demand into a fuel consumption, and that's of course done with the specific fuel curve. So this is quite an efficient auxiliary engine. We're gonna call it engine phase. We have a 4-stroke medium speed. If we're gonna make a high speed, you see that it's slightly higher specific fuel consumption, and we can also manually decrease or increase the specific fuel consumption so that it nicely matches your own specific fuel consumption. And then we have an overview, and here we can simply compare to see how the energy demand and also fuel demand from the specific fuel curve translate into a fuel consumption per day in kilograms and liters, and then finally also electricity or fuel OPEX here at the end. These are indicatory. Again, much more can be made customizable, but we usually sit down with ship owners to see, okay, is this indeed your average fuel consumption while you are running on your auxiliary generator? So it's used to get a overview of the running costs and consumption of your ship, and to make sure that it's close to reality. If that's the case, then we can move on to the second part, which is the equipment and the equipment. Nothing more. So here we have an isometric view of the equipment required. In this case it's a direct drive. Well, I'm guessing it's actually a diesel electric, so you can see that changes your equipment view. What's important? Well, we have rated power here, so this is the maximum rated power of the shore power equipment in kilowatts. I believe that should be around 16 megawatts for a cruise ship type, so this is pretty close to what's required, but you could manually reduce it, and it will certainly impact the costs a lot. 100,000 kilowatts, no, 10 megawatts. Let's see, one more. So that's a lot of zeros. Yeah, that's of course what I need to have. 1, 2, 3, 10 megawatts. That was what I was looking for. Rated voltage and frequency, also important. Mostly they are used for determining whether or not you need a transformer. That's here, so you can include that. That's mostly for pricing. You can also change it later, but most importantly, do you also need refitting your switch port, or do you still have a space allocated for a shore power connection? For cruise ships, it's pretty important to have these straight. As you can see here, it will greatly impact your total costs, because this is really at the heart of the electrical equipment. You can choose the amount of connection panels, starboard, port side, either way. That also impacts prices greatly, because you need additional cabling and Connection panels, of course, and then finally, above 1 megawatt, it's typically considered high voltage shore power system. Below, it's typically considered low voltage shore power system. And we currently only look at synchronization for a switchover philosophy, but you could also do blackouts. Wouldn't recommend it when you have all those people having a great time on board. So here there's some more technical information and assumptions on the different systems. So you see a generalized electrical single line diagram, a generalized general arrangement. You need to look for yourself in your general arrangement to see which bulkheads need to be penetrated, how long the cabling needs to be from switchboard to, of course, the connection panel, etc. We can help, but this is simply to give you some help. So take that into account. And here you see also the system requirements for sockets and plugs, which can be different for different ship types. Once we're done with the equipment and we have the technical details in order, then we can go to Capex and OPEX. And here we have the resulting Capex with a payback time, which we will consider in business case. Probably the more you use shore power, of course, if you have cost savings, you will actually get money back. We can also add design and refit and class, and I'll show you later that, of course, for this ship type, this is not a lot of money compared to the equipment. So let's have a closer look. Here we see a breakdown of the Capex required, and we see also a large breakdown table, and this is actually where you see all our line items being added up into a specific cost that lead, of course, to our Capex. And what we can do here is we can change the internal hours here, internal hours or the external hours, to see how these costs would line up in order to, in the future, of course, get a better estimate of your specific case. We can also add a slight refit complexity that mostly impacts the man hours required. The equipment itself, if you need more complicated equipment, it will be a bit more expensive, but you can also use the Capex multiplier to get a quick estimate, quick and dirty, on the total costs and how it would impact your specific case. Then we'll have a look at OPEX, and here you see, so actually when using shore power you save a lot in terms of fuel, but that all depends on the fuel price, of course. More customizable options in the business case, but here you can already see LNG, for example, if we change the price, how that would impact the total costs. Also shore power electricity costs, engine maintenance. In this particular case it doesn't matter much, but we'll just leave it as is. Same applies to spares and consumables. Okay, that doesn't really matter for this case. EU ETS, well, that certainly impacts a significant amount of cost, but recently it went down, so we'll just leave it at 60. This helps us to determine that, electricity and LNG are the most important OPEX parameters we have to consider in our business case. I'll come back to reporting year and fuel EU later. Let's first go to the business case itself. Here we go. This is, of course, what we want to see. Lots of money being made. But is this real? I don't know. Again, we simply provide you with the tools. You need to make sure that the input is correct, but then the output would be close to reality. Let's have a look at the biggest sliders that we have. So in this case, of the 120 days per year that we are moored, we have 120 days per year connected to shore power. So we directly connect to the shore power. Installation always works. Well, nothing always works, so let's just slide it a bit and see. Okay, so that does impact our business case a lot, but I have to say, between 120 days or maybe half, I would still consider these payback times okay, good enough. Within 2 or 3 years, saving this amount of money and this on the long term, that would be nice. So it mostly depends on our fuel price, and there we go. We see that at a certain fuel cost, well, in this case we use LNG on our auxiliary engine. I'm not sure if that's really the case. Could be MDO. We can change that, of course, in the premium version. But yeah, this would mostly impact the business case, and then of course coupled with electricity. So We see that both these impact the business case a lot, but especially at this turning point, let's say about 500 euros per cubic meter for LNG. Well, probably easy to do it in metric tons, but there is a price parity at which it becomes a good or a bad business case. What we then can do, if we have like a mediocre business case, we can always have a look at the option, what would happen if we lease the equipment. Then of course we have a higher OPEX, we translate Capex into an OPEX, but a maximum exposure would be a lot less in this case. So 5 point something million, and here 2.9 million. So still leaving a slightly similar payback time. With leasing or financing of the equipment, it would be roughly a year later, but still it would be doable. So we can customize the business case and the leasing options, financing options here, so we can see how it will impact our total exposure and the amount of interest paid. And we can also add to inflation, see how that would impact our business case, net present value, especially for the CFOs under us. And finally EU ETS, and this one is important, nice bridge to FuelEU Maritime. The reporting year is quite important for especially some ship types. For this ship type maybe a little bit less, but we've added reporting year so that you can also look ahead in the future how FuelEU will impact your business case. And as you can see, there's some funny things happening at the end, but the further we go into the future, the more impact FuelEU will have on your total OPEX. I'll show you here. So here we see that FuelEU will actually become a higher contributing factor if you do not have shore power, but for passenger ships and container ships I believe it's mandatory, but it will greatly impact your total costs in the end. So we're going to leave it at 2025 for now. Have a look here and see how it will impact your specific ship. I can guarantee you it will be a lot. In this case, we see that conventional and for using shore power in 2025, we do not incur any penalties. That will be 2030 for a conventional ship with these specifications, and then going to 2040, I believe. Yeah. Only then will a penalty be incurred because our target is actually below the achieved carbon greenhouse gas intensity. So if we go to show more, then you can also see how we calculated stuff. Here you see every year with the compliance balance calculated, etc. In the premium version in Excel, I'll show you more. There you can also have a look at the formulas we used. I was actually a bit confused that having shore power would benefit you so much, but it's mostly because here it's added twice as far as we can tell. So we're gonna double check the regulations to make sure that we are not double counting. Again, check it for yourself as well, but it appears that shore power input or zero emission electricity input is of a great advantage, and you can see we have a 7 million cost savings over the first 10 years, and then 140 million euros of cost savings excluding the penalty multiplier in the entire future. I'm pretty doubtful that will actually be the case, but then again, who knows. And here you can also input the up to like the nanometer accuracy, the average main fuel consumption in metric tons per year. So you can change this to see how it will impact your total FuelEU penalty. If you want to learn more about FuelEU, you can click this link, and there we have some more tools as well, some better information that you can use in order to get a better estimate for your ship. And finally, we can also add subsidies. Currently our list of subsidies is quite limited, localized to where we are working and operating, but you can add a certain amount of subsidy and see how it will impact your business case. When I saw this, I was a bit scared that it wasn't working, but as you can see here, subsidy, even if you have millions of euros of subsidy, well, it's always nice to have millions of euros, but it won't benefit your business case as much as a different pricing for LNG or shore power price would do. So still, you can input a certain amount of subsidies if you have them. Moving on to the final part. Once we've made our case study, we can of course enter our ship name, lovely cruise, and email address. I'm going to use my own in order to get a customized report. And this report is a freemium version if you're using freemium one. If you are using the premium version, or if you are a member, you can simply download the Excel and you can build it all yourself. So, and here we go. I'm glad we went through the entire web tool, because that will save us a lot of time in the Excel. And here you see the instructions and the tutorial. What I'll do is I'll quickly highlight some of the ways we have calculated things. Again, it's a very complicated and big sheet. I would advise you to stick to the input and the report section for ease of convenience, but of course feel free to check everything out as well. So what do we have? We have input, where we input all the information of the ship. We have a report where we can print the report, Ctrl+P. Then we have output with all the detailed information and also cash flow information over the years. Then we have key information from the standards, power profiles, that's where we calculate the energy demands, etc. You can also input your own power profile if you want. Then we have different tabs with CII, EEXI, EU ETS and Fuel U, where all the calculations are made. Finally, we have some databases, the fuel and emissions database, where we have information on different fuels. You can also input a different fuel if you want to compare it while on shore power. And then we have the specific fuel curve information for main and auxiliary engines. And finally, a list of somewhat standardized ship types. Here we see the ship types and the main ship types. And the main ship types are important for rules and regulations, and ship types simply give us a pre-population of specific data that we can easily use to make business cases. So I'm gonna stick for the most part to input, report, output and fuel U probably, and the rest should be somewhat self-explanatory, but I'll guide you through all the different details just to make sure that you know what to do. Most importantly, what to do is to get the correct ship type here. So pick your ship type and also a ship main type. Both are important because they relate to everything, how everything is calculated in the Excel sheet. So if you change this to your own ship type, some things might not be available or not found. Keep that in mind. So we use mostly VLOOKUPs in our ship data table, as you can see, in order to match that column header in that specific database, so we automatically retrieve information from that data. Good tip of advice, some advice, keep a copy of this Excel sheet in case you break stuff, or contact the help desk if you need more. The ship name is also automatically retrieved, but we can change it later. IMO number, that's also important for especially the pictures. Here we see also some nice pictures that are included. Where is it? Yeah. If you delete some of the information, those might not come out precisely. The drivetrain, also important with respect to the picture links. And here we can see that we can change the different fuel types, MDO, and also here I'll make sure to add the drop-down menu. This information, also the main engine, not necessarily important for our business case, but you can change them if you want. And here the auxiliary engine, in particular the auxiliary power maximum, and also details on the specific fuel curve can be changed. But here you can simply override them easily with your specific value. And then again, the parasitic load, in this case 5%, overriding specific fuel consumption, and then main switchboard voltage and frequency. As you can see, tooltips are used to give you some extra information, but feel free to contact us if you need any help. Then we have the operational input, so the amount of days sailing, idle moored and on shore power. We generally take 90% of the idle moored days to be shore power days, and then also the average sailing engine load and auxiliary engine load. And these are important because they translate into an average power demand. We can also add peaks in the power demand, and those will then be incorporated here. As you can see, we simply look at, let's say, a standard day or year, because we average the power profile. Looking at it per day or per year doesn't matter much, because we take an average day and multiply it with 365. But here you see how we plot all the different power profiles when sailing, when regular, conventional idle moored, and when on shore power. And then you see the power demands over time. Input your own power profile if you have them here to get a better estimate of your case study. So finally, we also calculate the amount of kilowatt hours that goes into the fuel EU calculations. As you saw, it can be quite high, especially moving towards the future. So what we do is we go to the average amount of fuel consumed in kilowatt hours and then multiply it with the according factors, amount of days per year, in order to get the megajoules per year needed. Fuel prices, you can change them here. If you're going to do fancy calculations in business cases with your own fuels, make sure that the correct fuel price is included. And here we have the input table for the shore power equipment. As you saw, it should be rather self-explanatory. Why do we still have rated power, rated voltage and frequency? We have actually experienced chip owners who had a 60 Hertz switchboard and then said, well, let's put on 50 Hertz because it costs a lot less. We'll just take the extra maintenance for granted. So you can override the switchboard requirements here, and how that will impact your ship operations, it's hard to say, but well, that's why we have it here. Please check if you need a transformer or a switchboard, and this should be automatically done if it's below 1 MVA officially, so we use 1200 kilowatts. It's typically low voltage. If it's above, it's high voltage, but maybe you have different, or your class of verifier says something else. And then we have all the values for the business case, in particular reporting year, refit complexity, and Capex multiplier, as we saw, impact the entire business case. Here we can more granularly change the business case parameters, and also add subsidy, change inflation, see how leasing or not will impact the business case, and then finally changing the interest rates. And this is some beautiful text that accompanies the report itself. And if we have gone through all these different steps, we get a final report of, let's see, almost 38 pages that you can change accordingly, and it should give us all the information that we need, with of course the technical details and drawings over here. So that's the most important part of the Shore Power Excel. So this will give you your own control on the business case, or your own business case and control on it. What else can we do? We do calculate a lot more, also to incorporate it in the report. So here in output table, if you have a look, we have the key outputs, Capex breakdown on OPEX, and emissions saved. That's simply taking it from, as you can see here, all the different operational profiles that we calculate in power profiles, and there we get an average. And I have to say, this is quite tricky because depending on how you look at it, you can take an average of all the different operational profiles combined, or you can only look at conventional and idle mode. In some cases, for example, when looking at total CO2 emissions, we need to look at all the emissions per year in order to properly calculate CLI and EXI. So we've done that for the entire year with some estimates on the fuel consumption, of course. But when making a business case, well, because we don't know enough about your sailing profile, we have only looked at the conventional idle mode and shore power. That would give you either a reduced OPEX or a positive business case, because the sailing aspect would remain the same. So it's pretty tricky how it's built up. Contact us if you need more information, and change it if you want to change it, of course. And here we see the different years with the different cash flows, and finally we have the total breakdown of all the different line items needed for the Capex. Moving onwards, this is almost all databases. The same applies to power profiles. Well, this is not a database, but we simply take the input, sailing power, idle moored power, etc., and then calculate the average power, max power. For shore power, it's pretty basic, because you just simply take an average power consumption, maybe add some peaks here and there, in order to determine the max power and the average energy needed per day, and with that we can calculate everything we want. CII, EXI and Fuel EU are quite complicated mechanisms. We have different tools for them as well, different guidelines available online, so have a look at all these different steps. I'm not going to say these should be self-explanatory. I'm just going to say don't mess with them too much because, well, changing around the parameters will be very... Well, there's just a lot of links, and even in between the regulations, I don't know why they make it so confusing and complex. But, well, Fuel EU for this particular shore power case should be looked at for the most part. We have all the different calculations done here. We have also added here the well to tank and a tank to wake formula for your reference. One thing I do like to mention is that here a well to tank ship, according to these formulas, we do take into account the shore power energy into the system. I'm going to check to see if that's actually the case, because it looks like double dipping, because we have it in both well to tank and tank to wake formula. So have a look with your verifier also to see how they incorporate it. But we had a look at the regulation, does appear to be correct, so maybe it's simply added benefits for shore power at the moment until they change the regulations. And then finally we have the conventional versus shore power penalties per year. Everything else, fuel and emissions data, SFC data, these are all calculated. You can change them with your own specific engine, of course. And then ship data, input your ship information here, or simply override everything here at the input stage. So basically the structure as we have it is input. With input we get an average power demand. That average power demand here in power profiles is calculated into an energy need, which is transferred into a specific fuel consumption, and then finally into a fuel consumption in kilograms and also energy consumption in kilowatt hours per day, which provides us with everything we need in order to make detailed operational profiles and Capex estimates, and these are then translated into a Capex here and also a OPEX change, the day rate change, which then translates into a certain specific payback time. It is a lot, I have to admit. So again, I want to stress one final fact before we move on. Always contact the help desk to make your life easier. We started off with saying that I love it so much. I do. I've been working on shore power project since 2017. Still learning, still seeing the positive impact it can make, but it can be really complicated. Use this tool to make yourself a good business case. Reach out for help and contact the help desk in order to make your life easier. Thanks for watching this video and have a great day, and have fun with shore power.